Okay, now we have the pallet. We need to create also one box as the box that we actually need to be moved on as a package on the conveyor from the infeeder. You can do a model and empty solid, for example, a box, and let's say define it as you can, like, for example, let's say here, select this port as the reference at this point, I mean, and the length, let's say length to be 300, and then width to be 500, but let's say this should be minus 500. Oops. Minus does not accept minus, and then 300, 400, and then 300, so something like that. And then maybe it's better to define this position instead of that one, because then okay, how can I define this as a minus? The orientation, let's say 90 degree. No, 90 degree here. No, maybe here 90 degree also. No, so maybe to here we can make it 180, something like that. Yeah, and we can also a little bit shift it at this direction. Well, so just to be inserted exactly on the conveying system. All right, it looks good. Oh, it should also come a little bit down. So we define a box that is supposed to basically move on the conveyor. Okay, it's too much. Yeah, something like that. Okay, create this box and close. So we have one part here. We can also rename this part as box. Right, and I don't know if I need now to define the position of the conveyor, the pallets, but we can also move this conveyor later. We can define it that it belongs basically to the outfeeder. Yeah, later we can define it that it belongs to the outfeeder. Until now, oops, I realized that I have not actually saved this file, so let's save this as station 1 underscore palletizer. So we have now saved that, and all right, we will move. I guess we have everything that is needed for a simple palletization task. Just a moment, I take a look. Okay, yeah. So the next things that we need to define the basically the logic. So it is supposed that the box comes from the infeeder, moves from the infeeder, and moves to the left side, where we define a sensor to detect the sensor. The sensor detects the box, and then it will triggers the signal that basically triggers the robot to come and pick it up, and then it will place the box on the conveying system. For this one, we need to go to. All right, what we need to do is to go to this simulation, and then we have something as low station logic. We have to come here. I also need to go to the station logic from the other side and see what we have. We have an infeeder, we have an outfeeder, we have a gripper, which is here a vacuum, and then we have a feeder box. I need to know what exactly is this. So if we come to the design, so we have these guys here. Oh, by the way, I have realized that I have not basically inserted the controller of the. So before going forward, I go back, and so it is important when you are creating, after creating the layout, you can go to this robot system and you can click from layout, and that's create from the available model of the system, robot and its rail, a controller. And then the next step is that you need to define you need to go to the controller tab, and then you have to open this configuration and then go to the IO system. And when you go to the IO system, you will see this list. If you go to the signals, you will see this list that there are some predefined values for the basically signals. Then you need to create two signals. So basically I will name this as digital input underscore, so for example 10, and I create this as the digital input. And so this is the windows that you need to define this basically digital input in your system. And then click it OK. We close. Let's change another figure until the controller is restarted. Okay, so now I have one digital input. Again, I will create another one, not this one. Signal. And then I say that, all right, I will call this DO, for example, digital output number 10. I guess this is also the same. Yes. So digital output all and no and no and okay. So we have created basically 4 digital input and digital output together, 2 digital input to digital output, and it is beside all these signals that you see that are default signals, and there you can actually use it for a lot of applications, but we don't need them. Then we go back to this simulation tab, we go to the logic, we go to design, and you see that now the system has all those. The system appears here basically. Then we need to find out digital input and digital output if it is available. Well, I can't find it. Well, I guess I know why we cannot see these IOs, because we need to go to the controller and restart it, warm restart. I hope that it comes back when. Okay, we will restart the controller once. Go out from here. So input outputs. So we have now created, you see that's digital input, digital output number 10 and 11. They are available here, but the question is that why it's not clear. Yeah, basically why we don't see that in this. Oh yeah, okay, they are now available. Anyway, so you realize you have to go and activate it on the controller side here. After you save the configuration in the iOS system, you define it here. You see that they are already there. You need to restart the controller, and then you go to the simulation and you find that the system or the controller has this. But why I'm trying to actually I tell you why. Because we need to connect these guys together. Okay, we need to connect all these guys. So from infeeder, we have this one infeeder, and we have an outfeeder. But honestly, I think we need to change a lot of things. We don't need all these basically parameters or signals. All right. I would like to create some position. Show you how I would like to do that. But first, you have to define the basically the tool for the robot, because it's important that you have defined the tool, the frame of the tool, the orientation of the tool. For this, I'll show you how we can do that. But first, you need to realize why we need to define the tool. Let me do it again for you. So the position of the box is clear. It moves on the conveyor and it needs to be stopped somewhere. Let's say around that here. This is the position that the box needs to be stopped for the first conveyor, and then the robot needs to be called and pick up the boxes from here and of course place it on the pallet. So this is our tool. This is the vacuum that the suction cups that we have really considered as a tool. To make a tool, so I've already done that, but when you want to create a new tool, you go to the other section and then you create tool data. So when you create tool data, you have to define the tool data, the name of the tool data, and then the position of the tool data. You can enable these filters, for example, the surface and maybe this one. And I hope that you see, guys, everything that I am actually explaining here. Yeah, so you define the name and then the position. You can go, for example, this is important to know the the frame, the position of the frame. So then you need to somehow define the position of your frame, and then you click create. If there was any problem, and when you do that, actually when you go to the path and targets, and then under the system, and then you will find here your tool data, you will see that there's a tool 0 and tool data 1, and when you click on the tool data 1, you will see that the orientation of that. And here to select which tool you have, and here you see that there's a task, and there's a work object, and there is tool, and you can select it from tool 0, between tool 0, which is default value, and tool data 1. So I now select tool data 1. If you want to change the position or modify the offset, you can just right click, and then you set offset position or set position again, and then you define a new one. But I'm happy actually with the position or the current orientation, so I will keep it up, keep that. This is the first step to define the tool data, and then I need to teach my robot where is the position to pick up the box and where to place it back. So I think all right, if you, for example, want to jog the rail, you just go and right click and then select mechanism joint jog, and then here you see that you can move your robot right to left. And I would like to first keep this at the base position, and for pickup position, the place that the box is coming, use my robot, or jog my robot. So let's see. We have one linear option to jog our robot, and one joint option. For that, I try to use my linear jog. So first we need to rotate. I will go basically a little bit higher. So I need to go to move this direction, right? I go right, X, yeah, and then maybe a little bit in Y direction, but opposite. So like that, and then I need to come down, but actually I don't like this orientation, so I would like to rotate. So something like that. I would like to rotate like that, a little bit back. I hope that I'm actually moving the right direction. So, and then I need to take care of the frame. So my frame is also important to know it's my frame a little bit in epsilon or Y direction plus. Okay, a little bit more. All right. Okay, we are almost in the middle. So okay, and now I have to go down. So down, I go down, down, down. So somewhere like that. Yes, we are almost there. Yes. So this is the position that I probably pick up my box. So I need, in this position, basically I need to define one object or work object. So I go here and I click teach target. When I press teach target, when I go in the Pathfinder, in the work objects and targets, you see that I've created target number 10. I can change this target number 10 later, the name, but let's keep it at the moment as it is. Then I need to define one. Of course, it was better to do it before, but it's not dramatic. Then so this is our pickup position. Then I need to go up because I'm planning actually to put 1, 2, 3, 4 at the first layer, and 5, 6, 7, 8 box on each pallet every time that it loads. So 8 boxes should be loaded on the box. So on the pallet. So you need to define exactly where you put it back on the pallet. All right, so this is one thing, and then I need a like intermediate position that's after picking up to bring it higher at that position, and then go to put it down. So for that I move. I would like actually go higher, so I go this direction high. So again I try. So you see that the position is the position that we pick up everything. So I go up, and let's see how high we can go. It's almost high as so, something like that. And then it should not be so high as well, because we want to go in an optimized position. But because we have 2 stocks, so it shouldn't collide with the other packets boxes. That's why I go a little bit higher to avoid this. So like somewhere like that, and then I define this as the new. So I just click again teach target. So I have created a new teach target for this position. So I would call it target number 20 as the intermediate target for the box. Then I have to I would like to move, not a robot, but I would like to basically jog the mechanism, the railing system. So I move that a little bit to the right. Let's say I would go somewhere here, right? Because I don't want to collide with the system. So I go right somewhere like that in front of the packaging, right? And then at this position, I go back again to jog my robot and jog the mechanism. I would like to do it in the linear way, so it is easier to understand. So so again, I need to consider that x direction should be minus. So but to avoid collision, I move a little bit opposite in y direction. So like that, right? I go that. I'm a little bit trying to avoid the collision, so I go yeah, so z direction, no, sorry, y. If I'm correctly, it is in x direction, so I have to move in x direction. So you see that the robot is actually changing or rotating. So you see we are now in the intermediate, almost in the position of intermediate, but this is the place that is not the place that we like. So you see that the robot completely moved. So I need to now move back to the y a little bit this direction in order to be on top of the pallet, because it's important to be positioned on top of the pallets. We are so on top of the pallet, right? We are there, and then I need to maybe now define and the number again, another point for intermediate number 2, I would call it. So this is the position that maybe, but honestly I don't know if it makes sense to put it like the packages like this way. Okay, so yeah, we can also put it like that, but because 4 package needs to come side by side, so I would like to actually let's rotate this like that, so in a way that the packages come like this way and on the conveying system. So let's define now another point 4. So if you go to the path, you see that the target number is 30, which is another intermediate position. So we have 1 2 1 2, and the third number is, I don't know what is this one, it's a bug probably, but it is there. So this is the third position that we define. And then for the first one, we start from somewhere at the right or the left corner, and then because it's almost here, so we move somewhere in the middle of that position. So we have to go down, right? You have to go a little bit down, so we go down in Z direction. I hope that we do not go out of this working space position. So you see that we have a little bit, we are going a little bit wrong, so I need to move in direction, I think X a little bit this way. Yes, so I need to go up, and maybe here it's easier to see that. Yeah, somewhere like that. And the rotation also needs to be correct. I don't know why the correction, maybe now it makes sense instead of linear jogging to go to the joint jogging, because then we have more how to say, more possibility to correctly position, but this is not the part of this course. We can probably spend more time to correctly position. So that's why I say that, okay, for me it is all right. I need just to go a little bit down and as below as possible to put this package on the conveyor. Maybe a little bit also down. So somewhere like that. So a little bit maybe also down. Yes. I hope that it is not that. You can also, of course, like I think the size of the height of our box is 300. So I would say that let's this position. Let's consider from here. If I apply for this one and the surface is also selected, from here until the size of the package. So let's say from here, so it's about 194, which is a bit little, and that's why I need to go a little bit higher. So again, I would like to, I actually need to be sure about the position, the height. Oh, I think it was something like 300. Yes, it's 300. So again, I select the position. Oops, sorry. I don't know why I can't select basically. Why I can't select this surface? It's something strange for me as well. Don't know why. Because it doesn't make sense. Okay. But anyway, I think you've got what I mean. So almost a little bit maybe higher than we consider it's done. So something like that. So this is the first like put down position for the first package, right? I just keep it one more time from the top. Yeah. All right. Okay. Let's call this position as the target that we put down the first package. Then we need again to go up, and we go up. If I go up again, you will see that it's the position for putting down the first package is there. So of course, as I said, all of these work targets you can later define, do variation, change it, or whatever. So this is just educational purposes at the moment that I'm teaching you how to do it. So you go again up and until to reach the position that you are sure you're safe and do not collide. So I would say that like you could exactly use the same value for this robot, for this position, but I would like to maybe try a different, like a little bit easier, so not exactly here. So yeah, you can define again one target as you're done, right? So the target number 50. So target number 10, target 20, target 30, target 40, which is your place, your packet, and number target 50, and then you need to define a place that for all of the packages you can consider as a home position. It's one that the robot comes to that position and waits for the next box that goes on the or comes on the conveying system. So for that you need to like maybe go a little bit even more higher, and then move to X direction, like exactly the direction that was in the front side of the robot, right? Somewhere like that. Let me see that how is the position. So somewhere like that, and then you can basically, I'm sorry, just shut this. Then you can here define your home position or target. Okay, now we have done one round. All right, we have done one round, and these positions are defined. What other position we need to define is that if we consider 8 boxes to be palletized on each pallet, then we need to define the rest of the 8 box position on the pallet. Otherwise, all those basically targets can be used again. All right, now we have created all these tags. I would like to see that how it looks like. So if the robot moves to this position, so I can right click on that and then say that, okay, view robot at the target. So if I see the robots at the target would be like that, and then I go higher would be like that, then like that, then like that, then like that, and we are okay. So that would be the cycle of our pick and place. Now, after that, we need to somehow define the paths. So we need to define a path that all these objects are located. As I said, you can work on the extra like the other positions. I just simulate one cycle. It means that it pick up the box and put it in just one of these 8 boxes positions. So, but now I need to create a path. So I create an empty path, and then I would name it like path number 20 or something like that. And for delete this already, there is okay path number 20. So I need to put all these objects in the path. But before that, so you want to see that how your after creating this path, how your robot is actually looks like in this position. As I said, you can move your robot in different positions, and then in the path, after creating this pathway, here we can create pathway on empty path. I have named it as path 20. So I will put the first is the home position. I put home as the first, so it move L home, and then I would put pick position, and then pick mid. I have named it, and then comes to place, and then again place mid and return mid, and then again home. So this cycle, as you see, this is a cycle that the robot trajectory is created, goes down, 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 and we again back. So now we have completed the first cycle. Then the next step is actually to synchronize this to the Rapid. So what's Rapid basically? Here you see an option called Rapid. This is exactly where all those codes get generated, because whatever we are generating graphically needs to be translated into text format or in a way that the controller of the robot can understand it. So the Rapid code, we have now a module, and in this module there is a main module. I will go inside, and you see it's basically empty because we have not synced anything. So that's why we need to somehow synchronize what we have created in the graphical interface with the Rapid code. To do that, you have to synchronize to Rapid. So the first option is synchronize to Rapid. The match objects in the station to the Rapid code. So whatever you have created in the graphical needs to be converted to the Rapid. So when I hope that you guys see this. Unfortunately, this program cannot always show you. Let me see. Okay, I guess now you see this window. So I have to sync whatever exists basically in the graphical interface to the Rapid code, and I will select everything and then just press OK. So it takes some time to create. So as you see that it's updated, and we have some row targets that we defined, and a very simple program as the pass 20, which is located under the main program, and all those move, home position, pick position, meet position, place position, and again home is now here created. Then I go back to the simulation, and then I would like to see after synchronization to play this, how this program will behave when I play. So let's see. All right, to simulate this trajectory, I have to come and right click on the path and then select as set as simulation entry point. I have done it before already. So when I go to the simulation tab, when I play this simulation, it would be something like that. So moves down, pick up, and then coming to the destination place, and then again going to the home position. All right, this was the first part of the voxel. Then I think just a moment. This was the first part of the tutorial, I would say. The next part I will work on the simulation of the box moving on the conveyor, and how we can connect everything with the Rapid code to somehow sync the simulation or the motion of the robot to the motion of the box on the conveyor, and then putting on the conveyor belt. I will create, follow me just to be informed about the next steps. Then see you again.